Hi everyone, and welcome to today's session on modernizing your legacy data warehouse on AWS. My name is Jason Hunter. I'm a Principal Specialist Solutions Architect where I spend a lot of my time working with customers as part of their digital transformation journey with a specific focus towards value extraction out of their data assets. Today I'm joined with David Sear from Transurban, who will spend some time to take us through their own data warehouse modernization journey and the pathways they took to get there. Now, in terms of the agenda for today's session, I'm going to run through some of the signs that we have observed from our customers that have worked out to be pretty good predictors that it's time to start the modernization journey. We'll cover off some requirements that you will want to consider as part of your data warehouse modernization, as well as highlight some of the new features of Amazon Redshift. We'll then round this out with some approaches to consider, at which stage David will talk us through his team's data warehouse modernization journey. So let's get started and take a look at what exists today and has for a very long time. For an organization to be able to make informed data-driven decisions, it means your data professionals, such as your data analysts, your data scientists, and data enthusiasts, need to have access to the right data. Data warehouses are siloed and made accessible to a trusted few, normally technical users, and only visible by way of dashboards or reports. Access to this data is typically done through a push and pull model, where a user will push a request, maybe using a ticketing system, requesting access to a subset of data, where they will then pull or access that result by way of a dashboard that's been created for them, or a generated report file. Now, this is not conducive to running a productive data-driven decision environment, especially when speed really matters. Now, if we compare this to a modern data architecture, you're not only looking at making data more broadly accessible, but also more open and integrated with other core master data systems as well. If we have a look at the right-hand side of this diagram, we can see how the data warehouse has an open and portable integration with the data lake. This facilitates the sharing and access of datasets and technology, like machine learning, to cater for all types of data-driven projects and end-user requirements. Now, the way we think about this on AWS is by using what we've termed lakehouse architecture. As you can see from this diagram, part of your modernization goals should be to promote the highly trusted data in your data warehouse to be that of a first-class data provider inside your overall data architecture. That means making it accessible to additional connected systems and data consumers within your organization to allow for this accelerated data-driven decision making. So as part of your modernization journey, what should you be looking out for? What are some key items to consider? When we factor in the overall data architecture of an organization, a modern data warehouse needs to answer a variety of requirements outside of the traditional descriptive and diagnostic analytics. It's no longer sufficient to have static or batch loads of updates that are along the line of hours to days. Modern data warehouses have the ability to significantly reduce that time horizon to allow for a much wider set of questions to be answered, typically involving more advanced approaches leading to predictive and prescriptive analytics as well. Now, in addition to being able to generate value from a wider pool of data, it becomes increasingly more important on how you manage your data. Aligned closely with your data strategy is your data governance model. Now, your modern data warehouse needs to be able to seamlessly integrate with a single data catalog that is comprehensive and searchable, while also delivering industry-leading security and compliance that does not require additional costs. Now, running your modern data warehouse should also be simple and extensible. Your modern data warehouse needs to support a broad ecosystem of tools and consumption patterns to not only cater for machine-to-machine communication, but also for a number of different data languages and tool sets for your data users, in addition to being able to streamline ways of transforming your data at scale and also automating your infrastructure management through code. And look, ultimately, this is all focused on reducing the amount of operational management of your data infrastructure, so you can really focus on delivering business value through data analytics. Unsurprisingly, you will find that these key requirements, driven predominantly from industry and customers, have been very influential towards the features we build for Amazon Redshift. Amazon Redshift continues to innovate at such a fast clip that it's worth pointing out a few notable features that deliver against these key data platform requirements. Picking up some examples, let's take a look at the Data API. This is a programmatic way to access your highly trusted data. As an example, you could choose to share a subset of your data for export by way of an application programming interface or an API. Sharing data in this context does not mean physically moving the data, but instead creating a logical shared view of it. Now, while this data can be accessed through various tools and business intelligence applications, in this case, you could choose to use the Redshift Data API for programmatic access to allow for a range of data languages and tools to integrate it into their own systems, or even be accessed by trusted third-party sources. From a performance standpoint, there's Aqua for Amazon Redshift. Aqua, or Advanced Query Accelerator, provides a new distributed and hardware cache that brings compute to the storage layer of your data assets, typically delivering up to 10 times faster query performance than other cloud data warehouses. There's also no additional cost for this feature, and it applies to all Amazon Redshift clusters that are running on the RA3 node types. A final feature to talk to is Amazon Redshift Machine Learning, which makes it incredibly easy for data analysts and developers to create, train, and apply machine learning models using SQL commands in Amazon Redshift. For example, you can use existing operational data inside Amazon Redshift to train a churn detection model, and then apply that model to your results. You do this by simply publishing your model as a function, which you can then use in your SQL statements. This makes it very easy to embed prediction models like fraud detection, risk scoring, and churn predictions directly into your queries and reports for consumption across your organization. So how to get started? Well, for self-service options, we provide a range of online resources, from white papers, blog posts, videos, and accelerators to aid you on your journey. Or there is the partner-supported approach, where you can look to bring in additional resources to help. We see customers using this partner method when either they are missing some of the technical skills or are resource constrained. In such cases, we have a range of AWS consulting partners that can help as part of your modernization journey and get you started. Working with one of our AWS consulting partners can help ensure you are using best practices and tools. Not only do our partners have extensive Amazon Redshift expertise, but you will find that they also have packaged Amazon Redshift consulting offers with a specific focus on starting and accelerating your data warehouse modernization journey. Regardless of the method you choose, so whether that's partner or self-led, there are a number of tools and technology to cover nearly any scenario you'd need to consider, especially when it comes to data movement and transformation to and from the AWS cloud. We also have a set of products that help you understand what changes would be required as you look to move across database vendors, which is a great starting point to understand what effort may be involved. For example, we have the service AWS Schema Conversion Tool, or SCT. SCT accelerates migrations by automatically converting your source database schema and a majority of your database code objects, such as views, store procedures, and functions, to a format compatible with Amazon Redshift. Now, any objects that may not be able to automatically be converted are clearly marked as such, so that they can be considered for manual conversion later. All of these insights are provided by way of a report file as well for offline review. Then we have AWS Database Migration Service. Database Migration Service helps with the migration of your database objects to AWS quickly and securely. This could be a one-off migration, or Database Migration Service can be used to continuously replicate your data with high availability into Amazon Redshift, in addition to an Amazon S3 backed data lake. Database Migration Service was designed to be simple. Typically, you can get started in less than 10 minutes to run some test workloads. And what this means is that it's really easy to run some experiments and understand the level of effort or potential changes that may be required as part of this step. So let's talk about where to start. A key part of the modernization journey is not just about the technology. It also encompasses people and process. Now, depending on where you are in your overall digital transformation journey, as part of your data warehouse modernization to Amazon Redshift, you may look to start small and work across a specific part of the business, or focus on a particular data product, say customer loyalty, and build it out from there. Using this approach is beneficial as it draws on being very focused towards delivering against a meaningful part of the business. Delivering value to that subset of the business will allow you to work much more closely with them and focus on their customer experience aspect. This will allow you to iterate faster, collect feedback, and apply those learnings to other business groups as you look to modernize their journey. This is also the time to unlock new use cases and mature or optimize current ways of working. For example, Amazon Redshift Machine Learning or the Redshift Data APIs can be used to promote and drive adoption and interest from other parts of the business that traditionally would have found other ways to source and act on that data. With the number of new enablement features that Amazon Redshift provides, now is a good time to think big and start to look for new business use cases to deliver against. A final point to note is in regards to experimentation. It's never been easier to create right-sized environments for testing out your experiments. And when you start to migrate a business use case across to Amazon Redshift, you can start small and scale the infrastructure and pricing models to meet your needs. We have a range of pricing constructs that allow for predictable pricing for long-term use, as well as on-demand pricing. At the same time, you can also look to modernize and enhance surrounding processes, such as ETL. We provide a number of serverless products that allow you to ingest data at scale in multiple modes of speed and to land that data inside your Amazon Redshift data warehouse. Starting out is easy. We provide sizing and cost models inside the AWS console to help you identify your starting point and to help you improve performance and optimize the operating costs for your Amazon Redshift cluster. Amazon Redshift Advisor offers you specific recommendations about changes to make. Amazon Redshift Advisor develops its customized recommendations by analyzing performance and usage metrics for your cluster over time. These tailored recommendations relate to operations and cluster settings. To help you prioritize any suggested optimizations, Advisor ranks these recommendations by order of impact for your consideration. I will now pass it over to David Sear from Transurban to take us through his team's data modernization journey using Amazon Redshift.
Hi, my name is David Sear. I'm an enterprise data engineer at Transurban, and I've been using Redshift for the past 5 or 6 years at Transurban. For those that haven't heard of Transurban, we are one of the world's largest toll road operators. Since starting out 20 years ago, operating a single toll road, we've grown to operate 21 toll roads across Australia and North America. We have nearly 9 million customers, and those customers take around 2 million trips daily on our roads. And we are one of the 15 biggest companies in Australia as listed on the stock exchange. So why is data important to Transurban? So we have lots of uses for data, just like any other company of our size, but we have a couple of fundamental uses that are perhaps more unique. Firstly, we want to make our roads more efficient, meaning we want traffic to flow on our roads, and of course our customers want traffic to flow on our roads too. Something people say at Transurban is that we're not in the business of making car parks. We want to make roads where the traffic flows, not where the traffic sits still. And secondly, we want to maintain safe roads. So we want to make sure our roads stay safe. We're very proud of the safety record on our roads. We have fewer recorded serious incidents than other equivalent roads. And we also want to maintain the safety of our incident response crews who are out there speeding up the flow of traffic again after an incident has occurred. So, what are some of our key data sources? So, like most service providers, we have a CRM system for our customers, and we have an ERP for internal resourcing and all sorts of other corporate systems for tracking things like workspace technology. What's unique to Transurban, we have toll gantries. So you've probably driven under some of those before. So these are gantries that collect data about vehicles as they pass underneath. We call that a passage. And we use that data to charge people for driving on our roads. Now we also have a lot of other roadside sensors collecting data. So there are traffic counting loops or studs every 500 metres along the roads in each lane. And also many of our roads have tunnels, and tunnels are absolutely full of sensors. There are sensors measuring air quality, lighting, exhaust fans, water pumps, all of the things that go into making a tunnel work. We monitor our roads 24/7 from roadside control rooms. Those control rooms have management systems that are used to control variable speed signs. They control the incident responses. They control all of the tunnel equipment. And of course, those systems produce event logs telling us what happened and when it happened. So that's a bit of general background on Transurban and our data. So going back to 2015, before we had Redshift in our life, what do we have? We're a relatively young company, so we don't have all these legacy mainframe systems lying around to worry about. What we did have is these roadside assets, each with its own roadside control system. Those control systems are safety critical systems. They're deliberately kept isolated from other control systems and from our other networks. We also had a big back office tolling and billing system and warehouse, and the warehouse there was sort of the de facto enterprise warehouse before we brought Redshift in. And of course all this data is in data silos, so this is the classic warehousing situation that every company faces. So we recognised that we could do better, and we started building a clean sheet analytics platform using AWS. Jason nicely described the modern data architecture, and that's very much what we were after. Back then, I'd never heard the term lakehouse. That's definitely what I'd call what we have now. We have a Redshift warehouse, S3 Lake, and an in-house Python framework that pulls all of our data together. Now, we were never running a lift and shift or big bang exercise here. We weren't replacing existing system. We were building a new capability, which is an enterprise data platform. And that was a very fortunate position to be in. It meant we could build this thing at our own pace. We didn't have to hit a deadline to cut over from an old system. It's also lucky that nobody expected us to have everything in there on day one, because of course, all those roadside systems, lots of systems, you're never going to be able to snap your fingers and get everything into your warehouse all at once. So if, as an early use case, as an example use case for our platform, we needed people on the roadside control systems to be able to access tolling system data to confirm that the performance of the tolling gantries was correct. So you can imagine you've got this tolling back office that's getting the messages from the roadside, turning it into passages and events. If those events aren't being processed properly or can't be processed properly by the tolling system, we have a problem, but the people on the roadside don't necessarily know that. So they needed to be able to get this information back into the roadside users. So tolling and billing system is a system we need to look at here. Redshift gave us some very important features out of the box in this space. So firstly, security. The tolling and billing systems contain very sensitive data, and we needed to fully comply with strict security policies. Redshift has familiar and comprehensive security access control features, and that helped us to get that sorted out very early on. That's a crucial step to get started. The second big thing was a very familiar user interface. So our existing analysts in the tolling and billing space, they use SQL. So giving them a tool like Redshift that is very familiar to them means they can come on the journey with us and work together to deliver maximum value in the minimum time. So we're confident that those things would work well with Redshift. We're a bit less confident about whether a columnar store database like Redshift could perform well on very, very transactional data with many joins on unsorted, unsequenced index columns. This system, the billing system in particular, has very high data churn. So there's about 5 terabytes or 10% of the total data gets updated each day. So it's not an insert-only system at all. So in other words, would a columnar store database be a good fit for querying data from a very row-based system or would we end up spending all of our time performance tuning queries to compensate for that? So this is where Redshift really pleasantly surprised us right from the start in that space. The very churny data loads, it might not be ideal, but it really wasn't a problem. And nowadays there's an auto vacuum feature that would make it even easier to deal with that kind of workflow. But much more importantly, we saw really huge performance improvements compared to the legacy warehouse straight away. We actually had somebody set up a Tableau dashboard for those gantry performance reports, and they accidentally left off the time filter. So instead of running for the past hour, it was running against every passage ever recorded on that asset, so 10 years worth of passages, and it was still working. It was happily running along and taking about 45 minutes, but it worked. So we didn't really have to fix that problem. Someone made a mistake, but crucially, we didn't have to fix the problem. Now that's similar. These days we have a very similar performance delta scenario with our end-to-end revenue leakage report that we can run today. Back on the old system, could only be run once a month, but now it takes less than 10 minutes to run, so we can run it every day. So that kind of big paradigm shift in performance for large queries was evident right from the start, and that was good news for our users. It was very good news for us too, because with performance being so good, we didn't have to spend much time on query tuning, so we could stay focused on acquiring new data, which, especially in the early days, is very important. So, speaking of acquiring new data, we had all these roadside control systems we needed to get on board. They came with a different set of challenges. So, all of the sensor and event data in those systems, it's highly varied in its format and structure, but it's all time series data, meaning it's all really mostly inserts, not many updates, so no churn, unlike the tolling and billing system. But our users typically want this data to be available quickly, so people want to see the traffic volumes as fast as possible. So we thought we'd probably have to be worried about lots of small loads causing high concurrency that might impact performance. And we're also looking at cumulatively high data volumes. CityLink in Melbourne, for example, has over 3,000 traffic and tunnel sensors, and they're all emitting metrics every 15 or 30 seconds, so the data volumes add up pretty fast. We've also got a growing user base now, and they started doing drag and drop analytics in Tableau. So these aren't skilled SQL practitioners necessarily. These are people that want to just grab data in Tableau and see what they can do with it. And they often want to do things like very long-term trend analysis. So they're not troubled by saying, can I see the last 10 years worth of data? So we're anticipating having to build aggregated data sets to give them really good performance. Now, here we are. We've got lots of these systems to integrate. That's going to keep us busy. But we're thinking we're probably going to wind up being bogged down optimizing these long-scale data sets for drag and drop users. Again, we were pleasantly surprised. We found that Redshift could soak up whatever those users could throw at it. They might not get the most lightning performance they wanted, but we didn't have to step in we typically didn't have to step in straight away. The users could get on with their work. We could get on with integrating new systems. The end users could get benefits straight away without us having to build big data warehouse style aggregation systems. We had workload management rules in place. That was enough to keep everything ticking along. No concurrency issues, no CPU or memory bottlenecks. Everyone got their fair share of the pie. And then when the current concurrency scaling feature was introduced, that was a nice little bonus. We find it does trigger a couple of times a day, so our cluster, we get 2 clusters for a little while to deal with higher demand, but it very rarely lasts for long enough to be charged any extra, so it's all covered under our free tier, which is great. And just as with the tolling and billing data, we found we could maintain focus on building new integrations rather than optimizing and dealing with our warehouse performance issues. And this is very much my key takeaway from my time using Redshift. With the performance being better than expected, we've had to spend less time query tuning than originally anticipated, and it's been very good. Along the way, we've had more pleasant surprises in the form of very useful features being introduced. So user-defined functions, that was early on. That's great for reducing code repetition. Store procedures, great for migrating legacy store procedures and building new internal workflows. The auto vacuum feature means you don't have to schedule your own manual vacuum processing. Very good if you've got churny data. Concurrency scaling feature, I've mentioned a couple of times, I think. We got a performance boost there, and it's typically for free. The RA3 node type, Again, we got a performance boost there this year. Geospatial support is coming through. We currently use Postgres for geospatial stuff, use database links back to Redshift, but we feel like maybe Redshift's going to get more mature. We might be able to not use the Postgres so much. So here back in the present day, as well as roadside tolling and billing data, we manage data from an ever-growing array of external and internal sources. Our in- and outbound data volumes are going up, but our load and query performance has actually improved, and our costs are stable. So volumes up, costs the same, performance up. That's a very good place to be. And to summarize our journey again, we had the luxury of being able to work at our own pace right from the start. Our end users have been working alongside us all the way, so we deliver what they want when they want it. They get the performance they need, and that means we don't have to work with them too much on performance. Redshift has consistently impressed, proven highly versatile. It works well for highly relational data and for time series data. It's kept pace with user demand despite remarkably little effort on behalf of my team for tuning the thing. The new features have helped. Almost all the features are useful when they come along. And another often forgotten thing, we have largely fixed cost with Redshift. It costs us a certain amount. It's a known cost. It's easy for us to quantify the value that our platform is providing to the business. There's no bill shock into our senior managers at the end of the year. Since 2015, we've only once scaled up our Redshift cluster, and that's far fewer times than we had anticipated. We thought we'd be scaling far more often than that, but it's just soaked up the workloads very well. Our in-house data engineering team's been slowly growing, but that's in response to demand for more data and value-add solutions, not simply to keep the lights on a bigger warehouse. Now, looking to the future, we expect our data volumes to grow very significantly with the introduction of connected autonomous vehicles and other smart features on our roads. So essentially, those sensors in our roads, there's going to be a lot more of them, and some of them are going to be inside cars. We're expecting that Redshift can continue to scale to meet our needs, and we're looking forward to nice new features like ML and other things that Jason highlighted. So Redshift's been great so far for us, and we expect it to only get better going forward. I'd like to thank Jason and AWS for inviting me along to share a little bit of Transurban's journey with Redshift.
Thanks, David. It's always great to hear from our customers on how they are using data to create new data products and innovate even faster. Look, if you want to kickstart your own journey and learn more about Amazon Redshift, visit our website. We have a large number of blog posts, videos, and stories from other customers like David on how they kickstarted their data flywheel using Amazon Redshift. We also have free digital online courses focusing on data and analytics to help accelerate your learning, as well as classroom offerings and instructor-led labs to get you familiar with the AWS portfolio of analytics services. Visit our training website link shown at the bottom of the screen for further details. With that said, thanks for watching. I hope you've enjoyed the content, and if you could, we'd appreciate it if you could take a minute to fill out the online survey. Thanks again.